In this video, we want to determine if a set of data points follows a normal distribution or not. Well, how might we do that? We can think of our cumulative probabilities table, which tells us relative to a z-score how much of the data have we surpassed so far. If we think of a z-score of 0, that places our data point right in the middle, so we would have seen 50% of the data so far. Right? So how can we think about this? Suppose we have a large set of data, but then we pick a sample out of that, and suppose our sample size is n equals 23. Well, let's look at the z-score of the first data point. If we write out all of these 23 data points in order, so the smallest value first up to the largest value at the end, and everything's written out in order, then let's look at what the z-score of the first data point should be. Well, how we do that is we plug this into the formula 1 over n plus 1, 1 being the first data point, n plus 1 being what we divide by. So 1 over n plus 1 is equal to 1 over 23 plus 1, or 1 over 24, which is approximately 0.04166. It's actually 0.0416 repeating, with the 6 repeating. So this is that value. What does that tell us? Well, that tells us that about 4.166% of the data should be below this first value. Well, if we look at our cumulative probabilities table, where do we get 4.166 repeating percent? It looks like that occurs at around negative 1.73 corresponds to about negative 1.73 of a z-score as a z-score. All right. And so how might we use that if we're trying to evaluate whether a certain data set follows a normal distribution or not? Well, you look at the actual value of your data set, right? We don't have the data set here, so we can't do this part, but what you would do is you would look at the actual value that first data point has. You would calculate the z-score of that, and you would see how close that is to negative 1.73. Now, it's probably not going to be exactly that value, but perhaps it's negative 1.8 or negative 1.62 or something like that. And if it's around that area, then maybe it's close to this value. And then we might keep going. We might do this for other data points. So let's suppose that we wanted to find the z-score. Let's find the z-score of the middle data point. If we get our middle data point here, so our middle data point would be value 12 out of 23. That would be the one right in the middle. So this would be 12 out of 23 plus 1, or in other words, 12 out of 24, which is 0.5. And what is the z-score for 0.5? Well, for a normal distribution, the median is right in the middle, right? And, well, median's always right in the middle of the data points, but it's also the mean for a normal distribution. So that z-score is that corresponding z-score is 0. And for 50% of the data, which is what 0.5 here represents. Okay, so again, what would that mean? That means if we look at our data point that is the middle data point, and we'd want to calculate the z-score of that, and if that came out to be approximately 0, then we're looking good for this data following a normal distribution. Let's go ahead and do one more. So let's find the z-score for the last data point. For the last data point. Well, this is 23 out of 23 plus 1, which is 23 24ths, which is approximately 0.9583 repeating, right? That's just 1 minus the 0.0416 repeating that we had earlier. Okay. So we get about this, or 95.83 with a 3 repeating percent of the data points so far. Well, what is the z-score that corresponds to 0.9583? If we look at our table, 0.9583, that is about 1.73. And this makes sense. It should actually be related to this previous value that we got was negative 1.73. It should now be positive 1.73 because we're the same distance on the other side of the middle, of the mean or median here. All right. So again, what would we do? We would check for the actual data point, what the actual data point for the 23rd point on our sample is. So what the actual value of that data point is. And we'd calculate the z-score of that. And if that was close to 1.73, then that would suggest we're close to a normal distribution here. And really what we'd want to do is we're taking the sample size of n equals 23 from our larger data set. So really what we would do is we'd do this for all 23 values and make sure that the z-scores we received are close to what they should be if this was a normal distribution. And if they're all really close, then we can expect this to probably be a normal distribution, whatever underlying data set is that we're pulling these 23 values from. And so that's the idea of what's going on. We just practiced with 3 of the data points here, and you see what's happening. And that's it for this video.